Hey guys, Jake here coming at you with another live math lesson today. Doing it live again this Monday evening. Today's October 3rd. Coming at you live every Monday night, 5 o'clock Pacific time, 8 o'clock Eastern. Got a few problems that we're going to be going over today. Kind of going back like I did last week to some pre-calculus topics. I've just kind of recently started doing a little bit more pre-calc on my channel just to make sure that people who are watching my calculus videos have a solid understanding of kind of the background prerequisite material that you need to have a good understanding of to do well in calculus. So I wanted to make some videos on some of those things. And today we're just going to be talking about basically graphing functions, functions in general, figuring out if certain points are on functions, all that kind of stuff. So I got a few examples that we're going to be going over. As always with these live streams though, if you do have any questions, feel free to throw them in the live chat as I go along, whether they're on topic or not. Even if there's some on topic questions, maybe there are questions about some problems you're stuck on for a homework assignment or something, throw them in the live chat. I'm happy to, help address them as well as I can on the spot. If I can't answer your questions live on the spot, maybe I'll make another video about it later on, where I can kind of prepare for it a little better. But either way, just throw those questions in the live chat. I'll do my best to help you right here, right now, so you don't have to go take those somewhere else to get your question answered. But anyway, let's go ahead and jump into the first example problem that I have for you here. We're going to start off with this one right here that you can see on the screen now. Determine whether each point lies on the graph of the equation. So really, when it comes to these kinds of problems, you're given some sort of equation. In this case, we have y equals x squared minus 3x plus 2. And then we have these 2 points that we need to figure out if they actually lie on the graph of this equation, which are 2, 0 and negative 2, 8. So really, when it comes to these kinds of problems, you want to think about pretty much one thing. What is a point? A point is just an xy pair. That's another way to think of it. Right? It's an x and a y pair. So this x and this y are paired together. If we were to think about what this actually looks like on a graph, basically 2 would correspond with where this point sits above the x-axis, and 0 would correspond with where this point sits in either to the left or to the right of the y-axis. So the 2 has to do with x, the 0 has to do with y. But when it comes to an equation, it's the same kind of idea. We don't have axes that we're looking at graphically, but the idea is the same, which is we have some xy pair. We know x is 2 in this case and y is 0 in this case. So if this point were to lie on the graph of this equation, that would mean that putting x equals 2 and y equals 0 into this equation for x and y, the equation would have to be true, right? Basically, the left side of our equation would need to equal the right side of our equation. If that is true, then this point lies on the graph of this function. If it's not, it doesn't. So to figure this out, all we have to do is replace all of our x's in our equation with the number 2, replace all of our y's in the equation with the number 0, and see if it's equal. So if you put 0 in for y, we're going to get 0 on the left side equals x, which is now 2, squared minus 3 times 2, because x is 2, plus 2. And that one's not an x. We just had a 2 in our equation right there. And then basically we need to figure out, are these two things equal? If they are, then the point lies on the graph. If they're not, it doesn't. So we really just want to kind of simplify from here. There's really no simplifying to do on the left side. We just have 0 equals something. On the right side, we want to keep in mind our order of operations. So order of operations says that we're going to deal with the power first. So 2 squared is 4. The next thing we would deal with is multiplication. So 3 times 2 would have to happen. And then the final thing would be addition and subtraction. So we'll kind of keep those 3 terms like that. And then we have 0 maybe equals 4 minus 6 plus 2. 4 minus 6 is negative 2, plus 2 is 0. So yes, those two things are equal. So we can get rid of our question mark. We know that 0 does equal 0, which means the point 2, 0 is on the graph of this equation. Okay, so we know that for that first one, the answer is yes. So let's go ahead and do this second point here now. Again, we basically just want to go to our equation, y equals x squared minus 3x plus 2. And we're just going to say, in this case, I'll actually get rid of all this real quick. In this case, we have, again, you're always just going to think of this as an xy pair. So xy. Negative 2 is x. So x equals negative 2. 8 is y. Y equals 8. And then we're just going to go to our equation and replace all of our x's with negative 2's, replace all of our y's with 8. So we have a y right here. That's 8 equals maybe with a question mark. We don't, the reason I put this question mark here is we don't know if the equation is equal until we actually simplify and make sure that both sides equal the same number. So until we actually kind of simplify it all the way down, we want to keep this question mark over the equal sign because we're not quite sure if those two things are going to be equal or not. Then we're going to have x equals negative 2. So it is important, make sure when you're plugging in numbers like a negative number like this, put it in parentheses because the whole negative 2 needs to be squared, not just the 2. Right? Writing negative 2 squared is not the same as writing negative 2 in parentheses all squared like that. The order of operations is going to give us something different there. So negative 2 all in parentheses squared minus 3 times negative 2. Again, make sure you're putting that negative 2 in parentheses. That's going to change things if you miss that. And then plus 2. So let's simplify the right side of our equation now. Again, the left side, there's no simplifying to do. We just have one number. Negative 2 squared is the same as negative 2 times negative 2. Two negative numbers multiply to a positive, so the negative signs are going to cancel out. 2 times 2 is 4. So this term right here is positive 4. Negative 3 times negative 2. Again, a negative times a negative cancels into a positive. 3 times 2 is 6. So we're going to get 4 plus 6 and then plus 2. So 4 plus 6 is 10 plus 2 is 12. So we have 12 on the right side of our equation, 8 on the left side. So these two things are not equal. So that tells us that at this point, negative 2, 8 is not on the graph of this equation. All right, if you are getting some value out of this video so far, do me a favor, hit that like button down below, just that little thumbs up button down there. It's a huge help to my channel. And hit that subscribe button while you're down there too. I do a live stream like this every Monday night, 5 o'clock Pacific time, 8 o'clock Eastern. So hit that subscribe button, that bell icon. You'll be notified when I go live each week and you can come join in, get any questions you have answered. I'm not seeing any questions in the live chat, so I'll keep on keeping on here. If you do have questions along the way, just throw those in the live chat. Happy to help answer any you have, even if they're off topic. As best I can live, at least. You never know what kind of questions you'll get, I guess. I might not be able to answer all of them, but I'll do my best. All right, so this next question we have here, we're going to complete the table, use the resulting solution points to sketch the graph of the equation. So our equation in this case is y equals 5 minus x squared. And here's the table we have. We basically just have these different xy points. And I'll just kind of make this a little bit thicker here so we can kind of see the difference. Basically, we just have these different x values. We need to fill in the y value that corresponds with that based on the equation that we're given here. And then we need to kind of rewrite them as xy pairs, which then we're going to graph. So first of all, let's go with pink. So first of all, what we need to do is figure out the y value that corresponds with each of these x values based on this equation. So to do that, what we need to do is go to our equation and replace all of our x's in our equation with whatever number is in our x row here, and figure out what y value we get out of our equation from doing that. So first of all, if we go to our equation here, y equals 5 minus 2x, or I'm sorry, 5 minus x squared. If we plug in negative 2, that basically just means we're replacing all of our x's. In this case, we only have one. We're replacing it with negative 2. So to do that, we basically just get rid of our x here, put in parentheses -2. So it is very important that you put that in parentheses like that, because if not, the negative isn't going to be dealt with properly. So doing that, based on order of operations says that we're going to do parentheses first, which -2 is the only thing in parentheses. There's not really anything to do with that. Nothing's happening in there. There's no operations being done inside the parentheses. Then is exponents. So exponents would be this squared here. So we need to square -2 first. So -2 squared is the same as saying -2 times -2. -2 times -2 is +4. The negatives cancel. 2 times 2 is 4. So in basically the parenthesis and this exponent here are going to simplify down to 4. So we're going to have 5 minus 4, because we still had this negative sign outside of the parentheses, and the squared canceled the negative sign inside the parentheses. So we have 5 minus 4, which is 1. So our y value that corresponds with x equals -2 is 1. Okay, so now we need to basically do the exact same thing with x equals -1 this time. So if we go to our equation, 5 minus x squared, replace the x with -1. Now we need to simplify that. So again, inside the parentheses, there's no operations being done. So the next order of operations operation that it says to do is the exponent. So -1 squared is the same as -1 times -1. -1 times -1 is +1. So everything right here simplifies to +1. So we have 5 minus +1. So 5 minus 1. 5 minus 1 is 4. So the y value corresponding with x equals -1 is 4. Okay. Then we do this for x equals 0. I'm hoping you're kind of getting the pattern here. We really just kind of keep going back to our original equation, replacing all of our x's with whatever x number we're given in this top row here. So in this case, 0 squared is 0. So 5 minus 0 is just 5. Then we replace our x with +1 this time. 1 squared is 1. So we have 5 minus 1, which is 4. And then similarly, we put in +2. 2 squared is 4. 5 minus 4 is 1. So these are the different y values. So now what we can do is we can create xy pairs from these xy combinations. So to do that, we really just kind of rewrite it as parenthesis, whatever your x number is, so -2, comma, whatever your y number is, 1. -1 for x, 4 for y. 0 for x, 5 for y. 1 for x, 4 for y. And 2 for x, 1 for y. So now we have these 5 different xy pairs here. And now what we can do is graph them. So to graph them, all you need to do is start out by drawing your xy axes. You want to get these as close to straight lines as you can. Obviously, that can be tough sometimes when you're drawing by hand. And then we want to label our horizontal axis as x, our vertical axis as y. That's kind of the standard way that you label your axes. Then we just want to kind of number them a bit. I mean, it doesn't have to be perfect, but we can see that all of our x and y values are between -5 and 5. So I'll just go up to 5 here, -5 over here. Our y values are all positive. So we don't even need to go down to the negative numbers, but I'll just go up to +5. We could definitely label all these. Whoops, that's not a 4. We probably don't really need to, as long as it's kind of clear that we're going by ones here in every direction. So I'll just label 5, -5, 5, and then you can see each tick mark is 1. So 1, 2, 3, 4, 5, 1, 2, 3, 4, 5, -1, -2, -3, -4, -5. And then, of course, your axes are 0. So basically, the y-axis is a 0 x number, and then your x-axis is the y value of 0. So now, to graph these points, what we want to do is looking at our axes, that'll basically tell us what number x and what number y we want to go to. So for this first point here, -2, 1, since x is your first number, y is your second number, we have x -2, y is 1. So we just go to -2 on the x-axis. So the x-axis is horizontal. So we go to -2 on the x-axis, which is right here. Then we kind of just imagine a vertical line basically going up and down all along that. Okay. Then we go to +1 on the y-axis right here. And you can just kind of imagine a horizontal line. If I can even draw a horizontal line. Going all across there. And then the point that we're trying to draw is just going to be wherever these two lines intersect with each other. So right here, x equals -2, y equals +1. We have this point right here. Okay, so I'm going to get rid of these lines, clean that up a little bit. But right here is going to be x -2, y 1. So that's going to be our first point right here. Okay. So then for the second point, -1, 4, we go to -1 on the x-axis. So keep in mind, whenever you're graphing points or graphing a function like this, you're always going to move left or right first, and then you're going to go up or down from there. So the x coordinate will always be the first one listed. That tells you where you go on your x-axis horizontally. Then the y coordinate, the second number, will tell you how far up or down to go. So -1, we're going to first go left and right. -1 is to the left, the negative numbers. So we're going to go to -1 right here. I shouldn't draw that point. That's not where our point is. But our point is going to be somewhere above this yellow dash here. Okay. Then we go to a y value of 4. Since that's positive, we're going to go up 4 units. 2, 3, 4. So right here is our second point. X equals -1, y equals +4. Okay. So then we have 0, 5. So whenever one of those numbers is 0, that means you're going to be on one of these axes. So since the first number is 0, first we go left or right. Well, if the first number is 0, we don't go left or right at all. We just move 0 units. So we stay at our y-axis. Then we're going to go up or down from there. Since our second number is 5, that's positive. We're going to go up 5 units from there. So up 5 units on the y-axis puts us right there. Then we're going to go 1, 4. So 1 unit right, left or right first. Since it's a positive number this time, we're going to go 1 unit in the positive direction. Then the second number is 4. We're going to go up 4 units from there. So up to y equals 4. Put our point right there. And then lastly, we have 2, 1. So 2 is our first number. We're going to move left or right first. Since it's a +2, we're going to move 2 units to the positive direction. So that puts us right here. So this point is going to be somewhere above or below this dash right here. Our second number is +1. We're going to go 1 unit up from there. So then we have that. So once we've graphed all of our points, if we were to then try and graph our full function, so we're trying to sketch a graph of the equation. So we're trying to sketch a graph of this entire equation. Of course, we have these 5 points right here, which we have graphed here. Once you've graphed your points, you kind of just want to connect the dots from there. So if we connect these dots, we're basically going to end up with something that looks like this, a nice downward facing parabola here. We could have kind of taken a little shortcut knowing it was going to be a downward facing parabola because we have a polynomial or a quadratic equation with the x squared term being a negative number. So since x squared is the highest degree within this polynomial, it's a second degree polynomial, the highest power of x. That tells us we have a quadratic, which means it's going to be a parabola shape like this. And since that term had a negative sign in front of it, that told us it was going to be a downward facing parabola, like this kind of a frowny face shape. So that's it for that problem. Yeah, if you are getting some value, hit that like button. Huge help to my channel. But let's keep on going here. I don't see any questions in the live chat. If you do have any questions, feel free to throw them in there, but I don't see any right now. So let's move on to our third example problem here. Find the x and y intercepts of the graph of the equation y equals square root of 2x minus 1. So there's a couple ways to do a problem like this. The first one would be to graph your function and look at your picture and see where it intersects with each of the x and y axis. You can also do this algebraically without having to deal with graphing. Personally, I think graphing probably adds extra steps that you don't necessarily need to deal with. And doing it algebraically is going to be more likely to get you the exact correct answer anyway. Instead of using a graph that you sketched, you're really just getting yourself an estimate. Doing it algebraically is going to get you the exact number that you want to get to. So that's probably the better way to do it. So I'll show you how to do it that way. Really, when it comes to finding x and y intercepts, what you want to do is think about just very, very quickly thinking about what a graph looks like. If we have an x and a y axis, thinking about, let's just say we have some function like this, okay? If we're thinking about our x and y intercepts, looking at the points that intersect with x, the places where your function intersects with x, what do you know about the y coordinate at those points? Well, the y coordinate is 0. They all happen at y equals 0. So to find x-intercepts, you want to look at the places where y equals 0. Okay, and then similarly, if we're trying to find the y-intercepts, the places where our function intersects with the y-axis, we want to look at where x equals 0. That's where the x-coordinate of our function is 0. So to find y-intercepts, you look at where x equals 0. So it's basically opposite. X-intercepts where y equals 0, y-intercepts where x equals 0. They just kind of go back and forth. So I just kind of drew this for the sake of talking about x and y-intercepts and what they mean. This is not what this equation looks like. That is not the correct graphing of that equation. I just quickly wanted to demonstrate what I meant by x and y-intercepts with a random function graphed over there. So getting back to this actual equation, to algebraically figure out where you have your x-intercepts, that is just where y equals 0. So if we go to our equation and replace the y with 0, so if y equals the square root of 2x minus 1, if we replace y with 0, that just gives us 0 equals the square root of 2x minus 1. Now, if we solve this equation for x, that should tell us where all of our x-intercepts are. And then similarly, if we go to our equation and we replace our x's with 0 and then solve for y, that should tell us where our y-intercepts are. So if we go to this equation, replace all of our x's with 0, in this case we just have one x right here, replace it with 0, we get y equals the square root of 2 times 0 minus 1. And then if we solve that equation for y, that should tell us our y-intercept. So basically we can kind of break this down into these two equations that we need to solve for either x or y to find our x or y intercepts. So let's start with this first one here. 0 equals the square root of 2x minus 1. We want to solve for x. So we're just trying to get the x all by itself. So we just want to kind of start thinking about how to start moving stuff over to the other side of the equation. To do this, what I like to do is think about order of operations, PEMDAS. Parenthesis, exponent, multiplication, division, addition, subtraction. When you're trying to solve for something on one side of the equation that has all these other operations happening to it, we're trying to solve for x. You can see here we have a square root going on. We're multiplying it by 2. We're subtracting 1. We have all these other operations happening to our x. Like if we were to plug in an x value here, we would have to do all these different operations to solve for this whole side of our equation. PEMDAS tells us the order that we would apply those operations. So we would first deal with what's inside the parenthesis or inside the square root. It behaves kind of the same. Within that, we would have to do the multiplication first and then the subtraction second. Well, the reason I bring up PEMDAS and the reason I bring all this up is because if we're trying to move all this stuff to the other side of the equation and get our x all by itself, we're going to do them in we're going to kind of move them over in the opposite order that we would do those operations to x. So if you imagine plugging in some value for x, the first thing you would do is multiply it by 2. So that's going to be the last operation we move over to the other side of the equation to solve for x. Okay, so first we would multiply by 2. Then we would subtract 1. Then we would square root it. So this is kind of the order we would go in. Times 2 minus 1, then square root. So we need to move these 3 things over to the left side of the equation in the opposite order. So we need to deal with the square root first. So dealing with the square root basically means we want to figure out what operation cancels the square root. Well, that would be squaring it, right? So if we square both sides of our equation, that'll cancel the square root on the right side and basically move it over to the other side. So 0 squared is just 0. So 0 squared is 0. The square root is now canceled, so we just have 2x minus 1 on the right side of our equation. Okay, so we dealt with the square root now. Now we need to deal with the minus 1. The opposite of minus 1 is plus 1. So if we add 1 to both sides of our equation, that'll cancel the minus 1 on the right side. 0 plus 1 over on the left side of our equation is 1. Since we canceled the minus 1 over here, we just have 2 times x. So we've dealt with the subtraction of 1. Now the last thing we need to deal with is the multiplying by 2. Well, the opposite of multiplying by 2 is dividing by 2. So if we divide both sides of our equation by 2, it'll cancel the 2 there, and we will just have x equals 1/2. So x equals 1/2 should be our x-intercept of this equation. Okay. Now we need to find our y-intercept by dealing with this equation here. So we have y equals the square root of 2 times 0 minus 1. So in this case, we already have the thing we're trying to solve for isolated. It's already by itself on one side of the equation. So what that means is to solve for this, we would actually just follow PEMDAS in the correct order. Parenthesis, exponent, multiplication, division, addition, subtraction. Because what we've done here is we've actually plugged in a 0 for x. So over here, I kept saying, if we were to plug in a number for x, what order would we deal with these different operations? Well, over here, that's exactly what we've done. We've just plugged in a number for x. We've plugged in 0 for x. So we would go in that same order. First, we deal with what's inside the square root, what's inside the parentheses, basically. Inside of there, the first thing that we have to do is multiplication. So 2 times 0 is our multiplication. 2 times 0 is 0. So we're going to have 0 minus 1 within our square root. Then we would deal with addition and subtraction. In this case, we have subtraction. So we have the square root of 0 minus 1, which is negative 1. Okay. And then from there, we're trying to take the square root of negative 1. Well, you can't take the square root of a negative number. So this actually does not exist. So what that means is there are no y-intercepts of this equation. And if we were to graph it, we would find that out, basically. You'd be able to see it graphically and visually, but also doing it algebraically this way confirms that the only value for y when x equals 0 is one that does not exist. You can't take the square root of a negative. So no y-intercept. We only have the x-intercept of 1/2, and that is all of our x and y-intercepts of this equation. So that's it. Still not seeing any questions in the live chat, so I'll go ahead and wrap things up there. If you did get some value out of this video, do me a huge favor, hit that like button and subscribe. Hit that bell icon. I go live every Monday night, 5 o'clock Pacific time, 8 o'clock Eastern. Hope to see you back next week so we can keep this brain train rolling. Maybe we'll come back to some pre-calc. Maybe we'll go back to some calculus. Not too sure. Drop a comment. Let me know your thoughts, what kind of problems you want to see me do next week, and hope to see you then. Thanks. Have a good rest of your week.